Hi everyone, for this lesson I'll show you the properties of a quadratic function. A quadratic function is in the form of y equals ax squared plus bx plus c. And a is the coefficient of x squared. It could be positive or negative. B is the coefficient for x and c is the constant. First case we're going to look at is when b and c are 0, so you'll end up with y equals ax squared. And the other case is when only b is 0, and you'll end up with y equals ax squared plus c. Alright, so we'll take a look at those two cases for this lesson. Alright, let's say we have this quadratic function which is y equals 2x squared, and what we can do is create a table of x and y values and use that to plot on a graph. So let's have x and y, and let's just pick some values for x. Let's say x is 0, x is negative 1, 1, negative 2, and 2. So the corresponding y values would be 0 for y if x is 0, because 0 squared times 2 is just 0. And negative 1 squared times 2 is 2. 1 squared times 2 is also 2. And negative 2 squared times 2 is 8. And 2 squared times 2 is also 8. So what we're going to do is plot these values on the coordinate plane. Alright, so we're ready to plot these points. So let's start off with this one here with 0, 0, negative 1, 2, 1, 2, negative 2, 8, and 2, 8. Notice on the y-axis the scale is by 2, each block is 2 units. And for the x-axis it's just by 1. Alright, what we can do now is connect the dots. Okay. And essentially we created the graph for the quadratic function, and this is called a parabola. It's this U-shaped graph here that we just traced over. You can also use fluid math to graph the quadratic function that we just did. So this one here is y equals 2x squared, and we did that on the coordinate plane, and this is the printout on fluid math when you graph it. Now you notice that if a, which is the coefficient of x squared, if a is positive or greater than 0, then the parabola opens upward, just like this here. However, if you have a less than 0, for example, let's say you have this quadratic function y equals negative 2x squared, then on the graph over here, the parabola opens downward. So it'll look something like this. Alright, let's take a look at these two parabolas. The red one was the y equals 2x squared, right, that we did. Now the blue one is narrower than the red one. If that's the case, then the a is bigger. So for instance, the blue one is represented by this quadratic function, which is y equals 7x squared. Alright, let's summarize this concept here. If the coefficient of x squared or the absolute value of the coefficient of x squared is smaller or less than the other coefficient of x squared, then the wider the parabola. So for example, here we have 2, and it's represented by m. So we'll take the absolute value of m. And the 7 is represented by n, or we'll take the absolute value of n. Now, if we take the absolute value of m and it's less than the absolute value of n, since 2 is less than 7, then if you look at the parabola, the 2 is wider than the blue parabola. Or you can say it another way. The blue parabola is narrower than the red parabola. Alright, we're almost done here. Looking at the 3 parabolas here, the green one, the blue one, and the red one, we know that for the green one, the coefficient of x squared, which is represented by a, is less than 0. And for both the blue and the red, we know that a is greater than 0. And we also know that the coefficient of x squared for the blue parabola is bigger than the coefficient of x squared for the red parabola. And we're done, and we're happy.